So this video covers the fifth problem in the second worksheet on nominal and effective interest rates. In this case, a city in the Northeast is evaluating the cost of a bridge. The bridge scheduled maintenance of $300,000 every 10 years for the next 100 years. What is the present value of these maintenance costs if the interest rate is 10% compounded yearly? So what we're doing here is we're actually looking at a very different way of defining a period and looking at how to solve this problem in a couple different ways. So the first thing I always would like to do is draw a cash flow diagram. So every 10 years we have $300,000 all the way to year 100. So what I'm going to do initially is I'm going to actually define a period as 10 years. So the period is not 1 year, it's actually 10 years. And so in that case, the K, which is defined as the number of subperiods per year, is 1/10. So every year is 1/10 of a period. So also we established the R value is 10%, the M value is 1% because it's compounded yearly. So just plugging into this equation again, we get a value of 159.4% per year. So one way to look at it is you look back at this equation, it's 1 plus 10% compounded for 10 years is what I've done. So I actually calculated the equivalent interest rate for a 10-year period is $159%. So then I'm going to go ahead and see, well, what's the present value of these cash flows? If I have $300,000 every 10 years for 10 periods, so that means I have 10 10-year periods. That's why the N is 10, and I have 159.4%. Now, obviously, there's not a table for 159.4, so I have to use the equation, but it ends up to be 188,192. Now I'm going to look at a different way of solving this so that we can contrast to see there's many different ways of getting to the answer for these engineering economy problems. So in this case, I'm going to define a period as 1 year. So K is equal to 1. And then when I'm doing that, the interest rate I'm going to be using is going to be equal to that that nominal rate because K and R are both equal to 1 year. So that means the I is 10%. So the way I'm then going to solve it is I'm going to take each of those $300,000 and bring them back to present value. The first one, I'm bringing it back 10 years. The second one, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I have all those calculations. But luckily that equation is pretty simple. It's just 1 over 1 plus the interest rate to the n power. So I can just do that calculation and I actually come up with the same